Hello viewers, you are welcome again to my channel. Alright, so this is a continuation of the series I'm doing on techniques to avoid electrical fire. This particular video is a continuation of the part 1 of how to select the correct size of cable. Alright, so in the first video, the part 1 of how to select the correct size of electric cable, I showed you a form that you can use to know the current carrying capacity of the various sizes of cables, considering the insulation on the cables and then the environment in which you are doing the wiring. Now, some of the parameters that were used in determining the current carrying capacity of those cables are fixed. Some of the parameters are also variable. They are not fixed. They can change from environment to environment. Now, some of the parameters that are fixed are the type of insulation used on the cable and then the size of the cable. But something like the environment in which you are doing the wiring can vary from one jurisdiction to another jurisdiction. Even in the same country, there are some parts of the same country that temperatures differ. All right, so if I take Ghana for instance, in the northern part of Ghana, temperatures are very high. And so, in case you are doing electrical wiring there, you have to be aware that because temperatures are high at that area, you will have to be careful when you are loading your cables. In the form that I showed you in the part 1 of this video, the ambient temperature that was used to determine the current carrying capacity of those cables we saw there is 30 degrees Celsius. But if the area that you are doing the wiring or the jurisdiction where you are doing the wiring has temperatures higher than 30 degrees Celsius, and the ambient temperature I'm talking about here is the temperature that will be around the cables after the installation. So you know that if you are doing concealed wiring, you have to pass pipes through the wall and the cables will be inside those pipes. So you know that temperatures inside the pipe that is inside the wall will be more than the temperature outside the wall. If you find yourself in areas where you know that the ambient temperature around your cables will be higher than 30 degrees Celsius, this video will help you to calculate, to know how much current your 1.5 or 2.5 cables can carry. And that will guide you when you are loading those cables. All right, so follow me as I explain this to you. Now, if you have watched my video and it is useful to you, please, the best thing you can do is to share so others can also benefit from it. You can share it to your groups and to individuals that you think would like to watch it. You have to do that for me. All right, so um, let's go. So, assuming that for the environment you are doing the wiring, the ambient temperature is 40 degrees Celsius. This row contains the ambient temperature. And then the column here is showing the operating temperature of the cable that you are using or the operating temperature of the insulation material used on the cable. All right, so we have it starting from 60 degrees Celsius up to 105 degrees Celsius. Then the ambient temperature range we have here starts from 25 degrees Celsius to 95 degrees Celsius. Okay, so let's assume that for your environment, you are considering an ambient temperature of 40 degrees Celsius. And so normally, most electrical cables that are used for domestic wiring, we have PVC as the insulation, okay? And PVC can operate within temperatures up to 70 degrees Celsius. So we are going to use a factor here that will help us to get the correct current carrying capacity of our cables in such an environment where we have 40 degrees Celsius of ambient temperature. So now our ambient temperature is 40 degrees Celsius. The insulating material is PVC. So we come here 40 degrees Celsius against PVC insulation. So we have 0.87. Now, what are we doing with this 0.87? All right, so from our first table, we know that 1.5 millimeter squared cable in a concealed wiring can carry up to a maximum of 14.5 amps. Now, we are using this same cable in an environment where the ambient temperature is 40 degrees Celsius and the cables are insulated with PVC. So we are using this factor to multiply the original 14.5 amps, and then that will give us the new current that our 1.5 cable can carry in this ambient temperature. So now it's going to be 14.5 multiplied by 0.87, and that will give us a new current of 12.65 amps. Now, because our ambient temperature has gone high, we now have the same 1.5 millimeter squared. Now it can carry only up to 12.615 amps effectively without overheating. And so what it means is that if we are connecting our 1.5 cables, we should ensure that the total load will not be more than 12 amps. In the first instance, where the ambient temperature was 30 degrees Celsius, we could connect loads up to 14 amps. But now the ambient temperature has gone high, and the higher the ambient temperature, the lower the current carrying capacity of the cable. The lower the operating temperature of the insulation used on the cable, the lower the current carrying capacity of the cable. And then smaller the cross-sectional area of the conductor, the lower the current carrying capacity of the cable. So these are things you should know. All right, so let's look at another example. Using this same table, let's assume that we want to connect 2.5 millimeter squared cable to a load. And then we are going to use concealed wiring. Concealed wiring means that the cables will pass through a pipe inside a wall. So from our first table, we learned that the current carrying capacity of a PVC insulated cable operating within an ambient temperature of 30 degrees Celsius can carry up to 20 amps. Now, we are assuming an ambient temperature of 40 degrees Celsius with the same cable. And so we are going to use this factor 0.87 to multiply 20 amps to see how much current this same cable can carry within this ambient temperature. So we are going to multiply 0.87 by 20 amps. And so here, our 2.5 millimeter squared cable in this environment can carry only up to 17.4 amps. And so whatever load you connect these cables to must not exceed 17.4 amps. All right, so thank you very much for your time. I hope you have gotten a guide or you have gotten an idea of how to go about selecting your cable sizes correctly in your next project. In my next video, I'll be talking about how to select the correct size of circuit protective device to protect your electrical wiring. And you have to watch that video also in full, because if you are able to correctly size your cables but you do not size your breakers correctly, you have still done nothing. And so the correct sizing of cables go hand in hand with the correct sizing of circuit protective devices. And so I wish you all the best in your electrical work. I am doing this in order to help to, as much as possible, prevent electrical fires. Thank you very much. Keep in touch.